All physical quantities can be expressed as combinations of some fundamental physical quantities. In the textbook, it says there are 4 fundamental physical quantities, but a more general accepted idea is that there are 7: length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Measurements of physical quantities are expressed in terms of units, which are standardized values. Without standardized units, it would be extremely difficult for scientists to express and compare measured values in a meaningful way. As shown in this picture, distances given in unknown units are simply useless. Since there are 7 fundamental physical quantities, the units in which they are measured are those called fundamental units. All other physical quantities can be expressed as a combination of these units. To convert from one type of unit to another, let's say we want to convert 80 meters to kilometers. We first list the unit that we have and the unit that we want to convert to, which are meters to kilometers. Then we determine our conversion factor relating the two units. In this example, we know that 1 kilometer equals to 1,000 meters. Next, we write the units and multiply them by the conversion factor so that the units cancel out. We get 80 meters equal to 0.08 kilometer. You may try a few unit conversions by yourself. Science is based on measurements. There are 2 words to describe a measurement. Accuracy is how close a measurement is to its correct value. Precision is how much the variation is between repeated measurements. Sometimes the measurements are both accurate and precise. In other cases, measurements can be accurate but not precise, or precise but not accurate. Suppose the correct value is at the center. In the left picture, all the doors are spread out quite far apart from one another, indicating low precision, but they are each rather close to the center, indicating high accuracy. In the right picture, all the doors are concentrated rather closely to each other, indicating high precision, but they are rather far away from the center, indicating low accuracy. The degree of accuracy and precision of a measuring system are related to the uncertainty in the measurements. You may have read the definitions of uncertainty and percent uncertainty in the textbook, and I will not repeat them here. The important thing is to understand that uncertainty can be thought of as a disclaimer for your measured values. For example, if you are saying the mileage on your car is 50,000 miles plus or minus 500 miles, then it means as long as the actual mileage is between 49,500 and 50,500 miles, you are telling the truth. One other concept related to the uncertainty is the significant figures. In the measurement, the last digit written down should be the first digit with some uncertainty. In calculations, there are several rules to determine the number of significant digits in the final answer. For multiplication and division, the result should have the same number of significant figures as the quantity having the least significant figures entering into the calculation. For addition and subtraction, the answer can contain no more decimal places than the least precise measurement. Finally, if a number is exact, it does not affect the number of significant figures in your calculation. You will get more practice using these rules in the group working problems. On many occasions, physicists, other scientists, and engineers need to make approximations for a particular quantity. As you develop problem-solving skills through the study of physics, you will also develop skills at approximating. Suppose we need to estimate the height of a 39-story building. We may think about the average height of an adult and approximate the height of the building by comparing the height of a person. If we use the fact that the height of one story is approximately equal to about the length of 2 adult humans, and each human is about 2 meters tall, then we can estimate the total length of the building to be 2 meters times 2 persons per story, that is 4 meters per story, times 39 stories, equals to 156 meters.